Welcome back. In this video we'll talk about two applications of counting multisets. Here's the first question. In how many ways can you distribute 20 identical balls into 5 labeled bins? Whenever you get a counting question, I find it very helpful to draw examples of the types of things that you're counting. In this example, we're counting distributions that look like this. We've got 5 bins. We can give them names A, B, C, D, and E. And we're putting 20 balls into these bins. Now there's 6 balls in the first bin, 2 balls in the second bin, 7 balls in the third bin, 5 balls in the fourth bin, and 0 balls in the last bin. That's a total of 20 balls put into these 5 different bins. Another distribution of the type that we're counting is this one. We have 4 balls in bin A, 3 balls in bin B, 5 balls in bin C, 4 balls in bin D, 4 balls in bin E. What makes one distribution different from another is how many balls are in each bin. So in order to answer this question, what we're going to do is we're going to see that counting distributions is actually the same as counting arrangements of stars and bars. Let's look at this first example. If we put 6, 2, 7, 5, and 0 balls in the bins, we would put 6, 2, 7, 5, and 0 balls between the dividers. Similarly, in this second example, if we have 4, 3, 5, 4, and 4 balls in the bins, we would put 4, 3, 5, 4, and 4 balls between the dividers. What we see is that the stars correspond to the identical balls in the bins, and the bars correspond to the dividers between the bins. And so there are 20 stars corresponding to the balls, and 4 bars corresponding to dividers between 5 bins. And so the total of such distributions is 24, choose 20, or 24, choose 4. Let's see another type of question that can be answered using multisets. How many non-negative integer solutions are there to the equation x1 plus x2 plus x3 is equal to 9? Again, it's really helpful to write down the types of objects that we're counting. These objects look like a choice of x1, x2, and x3, and we need that the sum of those numbers is 9. So one solution would be 3 plus 0 plus 6. That equals to 9. 2 plus 3 plus 4. That equals to 9. 0 plus 9 plus 0. That equals to 9. All of the x1, x2, and x3 are non-negative integers, which means 0 is allowed, and the sum of those 3 numbers is 9. Now here's the secret to this question. This is another stars and bars question in disguise. What we're doing is we're distributing 9 units amongst these 3 variables. Some of the units go into x1, some of the units go into x2, and some of the units go into x3. So when we see something that looks like 3, 0, and 6, we've put 3 units into x1, 0 units into x2, and 6 units into x3. If we see 2, 3, 4, that's 2 units in x1, 3 units in x2, 4 units in x3. And if we see 0, 9, 0, there's nothing in x1 and x3, and there's 9 units in x2. Remember, we put in bars to separate the different bins. And so we can see we have 3 bins in which we have to put 9 things. So the answer is 3 multi-choose 9, which when you apply the formula gives you 11 choose 9. All right, and here's another example of a multi-choose expression in which the upper part is smaller than the lower part. When you convert it to a binomial coefficient, you'll see that the upper part is always larger than the lower part. And let's finish off with a slight variation on this question. What if instead the question is how many positive integer solutions are there to the equation x1 plus x2 plus x3 equals 9 with x3 is greater than or equal to 3? Notice that the only difference here from the previous question is before we were dealing with non-negative integers, 0 is allowed, whereas now, because we're dealing with positive integer solutions, then 0 is not allowed. Furthermore, before, x1, x2, and x3 could be anything, but in this variation, we see that x3 has to be greater than or equal to 3. What are some objects of this form? Well, we could have 1, 1, and 7, These are all positive numbers. x3 is greater than or equal to 3. We could have 3, 3, and 3. They're all positive numbers, and x3 is greater than or equal to 3. Or we could have something like 2, 3, 4. That's still a valid answer. The difference in approaching this question compared to the previous example is that because x1 and x2 and x3 have a lower bound on their values, in effect we are pre-allocating units to the variables. We're saying that x1 is at least 1, x2 is at least 1, and x3 is at least 3, which means in bin A we have that there's at least 1 unit there, in bin B we have at least 1 unit, and in bin C we have at least 3 units. Those units are going to be pre-allocated to those bins. So that's 5 of the 9 total units that we're allowed to allocate, and so there are 4 unallocated units that we have left to distribute. And we've already seen that you could do that by putting all 4 extra balls into this bin. Or you could put 2 of these into bin A, and 2 of them into bin B, and then we get this example, 3, 3, 3. Or we can put 1 into A, 2 into B, and 1 into C, and that's going to give us this example. And so even though there are 9 total balls to distribute, we really are deciding the ways in which you can distribute 4 unallocated balls into the 3 bins, which we can do in 3 multi-choose 4 ways. Thanks for watching. See you next time.